Now we'll look at several examples of determining whether the first derivative is 0, positive, or negative at a given point on a function. The first derivative function value gives us the slope of the tangent line at a given value of x. So looking at this first graph, if we sketch a tangent line at this red point, notice how the slope would be positive, and therefore the first derivative is positive or greater than 0 at that point. Also notice that over this interval here, the function is increasing until it reaches this high point, and therefore the function is increasing over this interval, and therefore the first derivative would be positive over this entire interval as well. Looking at our second example, if we sketch a tangent line at this red point, notice how the slope of the tangent line would be negative, which means the first derivative is less than 0 at that point. Also notice this function is decreasing over this interval here, which means the first derivative would be negative over this entire interval. Let's take a look at two more examples. If we sketch a tangent line at this red point, notice how the slope of the tangent line would be negative, and therefore the first derivative is negative at that point. And once again, notice how the function is decreasing over this entire interval here, going downhill from left to right. Therefore, the first derivative would be negative over this entire interval. And now for our last example, we sketch a tangent line at this point here. Notice how this point is a low point on the graph, and therefore the slope of the tangent line would actually be horizontal. The slope of any horizontal line is 0, and therefore the first derivative is equal to 0 at that point. That also means the x-coordinate of this point would be a critical number. I hope you found this helpful.